Navy navigation. Hi, my name's Adrian, and I want to talk to you about Navy navigation and how to do this better in the future when we don't have GPS. That's very important. Without GPS. Now, our Navy operates in the ocean. That's the motion of the ocean. Below, there are creatures who swim in the ocean. Sometimes we have whales. Now, I would like it if we could talk to the animals and ask them where we are, but we can't. So we use something called GPS. Satellites, far out in space, sending down information to our Navy. Now, once our Navy knows where they are with GPS, they can do a lot of things, like navigate to the United States or to foreign wars. These things are very important, but how do we know where we are? When we use GPS, we standardize the way that we find our location, and that's using latitude and longitude. Let's remember latitude and longitude, because it's going to be very important when we discuss the things we use when we don't have latitude and longitude from GPS satellites. And those things are gyroscopes, beacons, stars, like the stars above us tonight in San Diego, and something very special called muons we'll get to at the end. What we do when we don't have GPS is we try to use a mixture of these pieces of information. All of these are sensors on our ship, and we can mix that information to find our latitude and longitude. Let's write down an example. Latitude, 48 degrees, 0.56. And then longitude, 175 degrees, 0.25. These are latitude and longitude measurements. But wait, when we don't have GPS and we try to use the gyroscope, we get error. So we use a plus or minus to explain how much error is in this gyroscope measurement of where we are, latitude and longitude. Let's say that error is 1%. 1% is the difference between sometimes being in San Diego and being in Los Angeles. Big difference. So we want to get this down to 0. 0 error in our latitude and longitude when we're navigating using the gyroscope. Now, how did we do this before we had GPS and gyroscopes? We used beacons. Beacons were available far away from the ship, on land, and we could broadcast all the way out to sea. And we had an antenna, and this antenna would receive the broadcast from the beacon, and that's how we knew where we were. But GPS replaced that, so no beacons. Now, the stars. Let's look up real quick. Maybe not as many stars as we want. But on the good nights, there are lots of stars. And if you know where we are, stars can be kind of like satellites. And then we use the star and where we are to tell where we are on Earth. But sometimes the stars can have lots of error. So the error in our stars can be sometimes as much as 2%. So that's no good. What Dr. Flores' thesis is describing is a way to combine these sensors all together to get a mixed composite to get a mixed composite measurement of where you are, or really a calculation based on the measurements in these devices. So our Navy now will use a combination of our sensors to get latitude and longitude. Now we're getting closer to good answers, because we sometimes know which ones have higher confidence, so we can trust those measurements more than others. But wait, I promise something very special at the end. Muons. Muons are particles emitted from space, and they are always coming down toward us. And these particles, of course, have a trajectory. And with new instruments that are not yet available today, we can measure these. And those muons contribute to a much better measurement. Hopefully, muons will give us 0% error. But that technology is not available right now. So what we intend to do is to investigate the next best thing, a combination of sensors and a composite measurement with a calculation that tells us where we are. So please read the paper, understand how we're figuring out where our Navy is, so our Navy can Navy with navigation. Thanks for watching this video.